Hi and welcome to the channel. Today we'll be going over how to set up a ZFS in XCP-NG. Now this is going to also apply to any Linux or most Linux file systems where you might be implementing ZFS. So to begin with, as you see in this situation, we got XCP-NG 8.3, but this applies to any other XCP-NG or Linux setup. Now I've already gone through this process in order to test my procedure and document everything. So this should be going fairly straightforward. Okay. So the first thing we're going to do is SSH into the server. If you're not sure what your server is, you can find it in the DHCP scope. Or in this case, as you can see, it's 172.16.69.251. Now I'm going to use just the Windows command prompt, but you can use PuTTY or whatever else you generally prefer to use for SSH. Now that we have logged in, because in this case we are talking about XCP-NG, which is based on CentOS, all of these commands will work for other Linux operating systems, but keep in mind, because this is based on CentOS, which is technically Red Hat, we're going to be using the yum command. DNF does not work as far as I'm aware in XCP-NG, but I might be wrong. For Ubuntu, you're going to be using sudo apt. And for the other ones, you'll be using whatever the appropriate command is to install the packages. But the remaining contexts will be all the same. Now we have two options here for XCP-NG. Now the preferred method will be to run the sudo yum install ZFS command, and then this here will only enable the REPL repo for this single install. Okay, the alternative would be to do sudo yum install epl. I will post it, but I will not execute it. Okay. I'm failing at copy paste right now. So the alternative would be to run this command, but this will enable it globally, which is for security. We do not want to do this. When I say security, I don't mean compromising security, but if we enable this natively in XCP-NG, it's possible that when you do updates, an update will break something in XCP-NG. So we do want to avoid this unless you're doing this purely for testing purposes. Okay, so the command we will be using is this one here, and I will post them below. Okay, so we're going to run sudo yum install ZFS. If you are running this procedure in Linux, you will just not use this next part to execute this. Now, as always, the recommended thing to do before you install anything on Linux, Linux related, you do want to do the update so it can fetch the latest packages, and then you would just execute the command to install ZFS with a temporary elevation to this repo based on updates. In my case, I have already installed it. Now you can, for the next part, either restart the system or you can run sudo modprobe ZFS. What that will do is it will just send a command to, I guess, check all the drives that are in there. We can check the ZFS version by running ZFS version. Okay, and my copy paste did not fail me this time. Now to get started, we're just going to run all the disks, sorry, we're going to check for all the disks we got in the system, and that should be a lowercase l. Okay. Now right now I have this part off of ZFS already. It doesn't really tell me that they're part of ZFS, but I'll show you later what that looks like, because if we run the command ZFS, you can see that I've got some pools. Now this will just look like a directory inside XCP-NG, so you can technically, or your Linux environment, you can technically dump anything in there. Your preferred method would be to throw everything into data sets and actually just run it in there instead of directly at the pool. Okay, I don't recall the real benefits, but I think as data sets you be able to do more snapshotting and other things with it as compared to attempting to run it directly on the pool, which for some reason XCP-NG lets you do, and I think it's not meant to let you. Again, I might be wrong. Now, if you do want to make sure that the disks you are repurposing are the correct disk, you can run this command, and again, I will post all of this below. This will tell you, give you more info, so it will give you the device ID, which we will be using. It will also tell you what that device is. Okay, so you don't accidentally wipe the disk that you do not want to wipe. So in this case, as you see, I've got some SSDs, I've got some NVMEs, I've got some SAS drives, more SSDs. Most of these are used, some of these are not. They're just in there as this is a lab server. Now that we run the command to get the ID for the appropriate drives, in my case, I'm going to actually just destroy. What I'm gonna do is destroy the SAS pool. Now you won't be doing this if you don't already have a pool. In my case, the SAS pool is just called my pool. Okay, this is because it's currently busy. I will have to just dump it out of XCP-NG, so give me a second. Now I'm gonna wait because I've got a VM that I use for testing. I'm just moving it on to network storage so I don't accidentally nuke it, so I can copy it back without having to redo it. So I'll be back in about 20 minutes and then I'll resume with the rest. At which point we're going to go to storage, find the pools that we no longer want part of this, and we're just going to disconnect them. So that's done under host, storage. We're just going to disconnect them and then forget them. But we'll do that in about 20 minutes. Okay, I've moved the VM. I've destroyed the first pool and I attempted to destroy the second pool, but it was not unmounted yet. So what I had to do is go into the pool in question, for example this one here, advanced and then remove. I'm obviously not removing this one, but that's fine, we'll deal with that in a second. So I will also just remove the SSD pool and we should be able to have a look. So the NVMe pool, look, that can probably stay still there. I'm not gonna recreate all of them. Alright, let's go back to the beginning. So we're going to just run this longer command, just again for the sake of sanity. We're going to figure out what we're gonna be using. So I already have a list of drives I'm going to be using. So I'm gonna be using I just realized that when I did my initial one, I added the wrong disk. I had some SSDs in the NVMe pool, in the SAS pools. So let me just compile that list again. I'm just going through the list and making sure I note all of these down. So SDK. The next one is SDQ. The next one is, so that's still Q. N. Okay, then we're going to be doing L. R. And then P. Okay, so after going through the whole list, this is what my command should look like to create a pool. Okay, so we're gonna do sudo zpool create force. This is the name of my pool. This is very important. The RAID type. In this example, I'm going to do RAID Z2. That means we have 2 disk redundancy. Now, technically, that means each of these subsets has a 2 disk redundancy. So I'm sacrificing, for example, these 2 in the first part, and then these 2 in the second part. Now, I'm not nominating these 2 exclusively. It just means 2 out of this batch can fail and 2 out of this batch can fail. So that means I'm technically losing 4 disks. So I should end up just over 4 terabytes because these are 1.1 terabytes each and there's 8 of them. There's not going to be extra performance gained by going with RAID Z2. I actually think you might lose performance, but again, I might be wrong. So we're creating one pool called mysaspool. We're going to do Z2, so 2 disks per, I think these are called VDAFs. Again, I might be wrong. So I'm sacrificing 4 disks in this case to create this. These names here are basically the disks that I've decided to use. So the HP, so that's P right there. The next one is R, and so on and so on. So I'm doing the the technically 1.2 terabyte SAS drives, and I'm going to just create. Now this can take a second, a minute. Usually it's fairly quick, and that has just created the SAS pool there. Now the next thing we're going to do is create a data set. Okay, and I've just, in my case, you can call it whatever. This is the name of the pool, which we nominated up here. In this case, instead of calling it that, I can just say SAS if I really wanted to. But it doesn't really make any difference. What you call it, as long as this makes sense to you, that's perfectly fine. So I'm just gonna leave it as I have it documented so I can more easily copy paste. Change this according to your own requirements. Okay, we have just created the data set. The next thing we're going to do is enable compression. Oh, bad copy paste. Sorry, I just realized I had the aircon on the last couple of minutes. Okay, we're enabling compression, and now this technically, so this needs to be SAS, because I renamed it just before I started this. This needs to match what we just created, or if you're applying this later. Now compression apparently does speed it up. It also makes deduplication possible on the data set. So this is something that's recommended because I called it, so I called my, let's just fix this up quickly. Okay, I'm just gonna destroy the data set. Okay, that should destroy the data set. We should be able to see if that's the case by going here. So the NVMe, so we do have the SAS pool, but no data set. So let's create a data set again. Again, sorry about the delay. Oh, always failing at copy paste. Okay. So mysaspool, obviously the definition for the pool, and data set. Again, you do not need to call this data set. You can call this whatever. You can call this VMs. You can call this files. Whatever makes sense to you. You can have more than one. So if, for example, I say data set, I can make data set 2, data set 3. I'm just giving you an example of what I've called them. And as you see, they're going to be all part of the same usage pool. Okay. So we've just created the data set there, as you see. Now, in order to add it to XCP-NG, the easiest will be, we're just going to go new storage, select the host in question, give it a name, my SAS. Okay, this makes zero difference of what you call it, again, as long as it makes sense to you. And we're just going to select ZFS from the list, and all the ones we have created will just show up. There's nothing extra you need to do. As you see, we've got the normal one, we got 2, we got 3, so that's NVMe. This is the normal SAS. We're just going to go create. So that's my main lab server, ZFS. Now, if you click ZFS and it does not show up, it means you have not really created a ZFS pool. If you thought you can just go in here and create it and it will do it for you, clearly that's wrong. So I'm gonna make a copy to this of that VM I just made, just to show you. Now here what I'm doing is I'm just selecting a VM that I set up the other day just for testing labs. I'll just give it a name. So this is currently on the NAS. Unfortunately, from the server that I've got this on only, well, it has a 10 gig network card, but it's not utilized. So this will take about 15 minutes to copy. And I have just selected the correct server, and as you see, it just shows up here. There's the data set we just created. I don't do any of this. I just leave that disabled, sorry. And I'm just gonna go copy or go OK. Now that will probably take about 15 minutes. And I'll be back when it copies. So there it is, 18 minutes. It will speed up a little bit later. So I'll be right back. Okay, now that the VM is copied, as we can see here, it's on that ZFS pool. Okay, we can see the disk user, so that's when it was copying. Okay, it was coming from a NAS, so it will be very slow. So let's just go back in here and run it. Okay, we're almost there. Now this is basically just me showing you that the disk works perfectly fine. Oh. I just did that the long way around for some reason. As we can see, that's running. Latency is very low. What I've just done is I did remote desktop. Let me actually fix. Okay, just so we get a full screen experience, I've just done remote desktop in, and I'm gonna run Crystal Disk Mark. So if we do 1 gig, Alright, it does take a second to create it, but let's see what the disk is doing. Okay, as we can see, IOPS are going up. Latency is still very good. If we compare that to, let's say, this here. I mean, it's got nothing running on it, it's a bad example. Okay, so that's about a gig throughput there. Now, of course, there's Windows updates. Nothing special there. Now I'm gonna let this run for a second. I'll speed forward it. Okay, the next part we're going to do is add an L2 ARC cache. So what that means is we're going to add a really fast NVMe drive or something faster than the core system, because these are the SAS, they're slow. They are faster than most cheaper mechanical disks, but because we are using this in a RAID Z2, we only kind of utilizing 4 disks. That's why we're getting this miserable speed. Okay, if we did a Z1, we probably get more speed, or if we just did a Z1 without splitting it. So yeah, let's just get to the ARC. Okay, in order to add the L2 ARC, we're just gonna see the list here. Actually, we generally want to do a ZFS pool. I'll just show you. Okay, so we got the NVMe one, and then we've got the SAS pool. I didn't bother recreating the rest. As you can see, we've got just 2 in here. Here we got 2 sets allowing us for redundancy of 2 disks each. Okay, so as I say, technically 4. So what we're going to do here is do this. We're gonna run this command. Oh, not that one. I have no idea where that information came from. So we're gonna do sudo zpool add, and then mysaspool, which is what this one is. That's the one with the SAS. We're going to nominate a function, and then we're going to nominate the disk we'll be adding. So let's just make sure that that is correct. So this is the disk we will be adding. It's just a Samsung NVMe SSD. Okay, now that has added it. Now if we go and run the pool again, you're going to see that we've got the pool and the cache is nominated. Now what I've noticed from my testing is that this does not necessarily speed up the VMs. Maybe in particular workloads. In my testing, unless you're going to be spamming the same functions a lot. So I can still imagine this improving the ZFS storage pool under certain conditions. Not in this case. So the way the L2 ARC works is basically going to cache things as they're being run on the ZFS pool in there as a temporary hold, and it will read from that instead of the pool where it can. It's a bit hit and miss, so you never know what you're gonna get. Now while this speed test is running, what I'm going to do is I'm going to add the SSD drives to the pool, just so I can show you how we're going to fix a broken ZFS array. So as always, we're going to start with this command here. This will show us the disks, and then I'm going to go through the list and add all the 1 terabyte SSDs. So give me a second. All right, now this is the command we'll be running. Not that one. I have no idea how I fail at copy paste that badly sometimes. Okay, so we're going to be creating the ZFS pool called my SSD pool. In this case, I'm just going to do RAID Z1. So we've got FD, so we got 1, 2, 3, 4, 5, 6. I have 7 SSDs in here, so I will randomly pull one out of these and replace it with one that has not been used yet. Okay, so here I'm gonna create it, and if we go up and do pool status, now we should see the SSD pool. As you see, we've got FDIGEJ, so 1, 2, 3, 4, 5, 6, and the pool is perfectly fine working. I can move some data on there and show you that it works, but it's a freshly created pool. These do work. They're just fine. So what I'm going to do next is just randomly pull out one. Okay, I've just pulled out a drive. So if we do ZFS pool, as you can see, F has been removed. Okay. Now this pool functions because we do have Z1, that means we can remove one. When I say remove one, it means we can have one fail, which is not a lot. One fail, and if you bought them from the same batch, it's very likely that the next one will shortly fail. So, which is why the Z2 is recommended. Now, usually you wouldn't do this for a small array. You would probably just do a Z2 and then just plop them in one command, as I've done here. Okay, where this the command run to? Okay, so I've just created a Z1, and I did not like previously split it where I said Z1 and then Z1 again, or Z2 Z2. It's one command. That means they're all part of one vdev. I think that's what they're called. Now you're going to start facing problems or more risk if you're going to be doing a Z1 with that many. Even a Z2, once you get to about 8 or more, and you should not really go over 10 at any point. It's not recommended. Okay, so let me just move on from that topic. So since this F is replaced, the command we're going to be utilizing to rebuild it. Okay, let me just find my little notes. So what we want to generally do is, now this is not a must, but what you generally want to do is mark the disk that has failed as offline. So in this case, because I randomly pulled one, it just happens to be the first one, we're going to go F. Okay, now that will mark that one as offline. So as you saw previously, just said removed. Now it says offline. So the command to replace it, we're going to do this, and I'll just edit it accordingly. Replace. So we are going to replace F. So on the left is going to be F, the old disk, and we are going to replace it with, let me look at the disk that I've got. We're going to be replacing it with H. Okay, so the command is basically zpool replace the name of the pool that you're replacing the disk for, which you can get off there. The old disk, so the one that has failed, which is being replaced by the following disk, and we're just gonna go OK, or hit enter, so to say. If we do that, you're up and running again. If this array did have some information, or pool had some information in there, you would probably see it resilvering. It would say resilvering, which means it's copying the data from the other disks. We're not going through that here. So if you do mess up and you need to just destroy the whole pool, the command is basically just sudo ZFS destroy and the name of the pool, and I call that one the SSD pool. Now if you're doing a data set, you would do the same thing, except you would possibly do like this. You would say the pool name and the data set. So what that will do is only destroy the data set, not the pool. Okay, does that make sense? Okay, now the next thing is, if you happen to have a ZFS pool that you pulled from a different device and you just want to map it here, you will just say ZFS pool import and then the name of that pool, whatever it was called. So let's pretend we had a server or a desktop that had a ZFS pool, or wherever you utilized it, and that machine is dead and you just need it somewhere else. You just run this command on that new location. Again, make sure that all the disks are connected firmly. You will be doing the disk checkup before that I showed you many times. Make sure all the disks from the previous pool are connected. ZFS doesn't really care if the disks are connected to the same hardware adapter, as long as it's in IT mode. It will just work. IT is in pass-through mode, so there is nothing, it will talk directly to the disk. So in this case, you would run that command and it will just import it. Now, we can't do that because it already exists. But you would run that command, it will import it. Now, if for some reason it does not work, okay, you can run this command. First, it will do like a more in-depth look to see. Now, you would run this command if the pool was destroyed. So if you've destroyed it before or somehow got destroyed, you would run this first and then followed by the actual pool name, my pool, whatever it's called. In this case, I obviously don't have one to show you this, but that should be straightforward. So we've gone over creating the ZFS arrays, assigning it in XCP-NG. Now you can do this, now you can't do that through the light interface, but you can do that through Nginx Center. Since I'm using XCP-NG 8.3, you have to get the next version, which you can find in my other XCP-NG videos. Okay, so we've gone creating the pools. You can create multiple pools, multiple data sets, destroying a pool, doing the L2 cache. We've done the repair. Now we do have this here, which will give you the zpool IO stats. So there's nothing much happening here right now. Let me see where I have left that off. Oh, sorry, that's in remote desktop. So if we run this again, now as you saw there, the even with the L2 arc, the performance hasn't gone up. It will be a noticeable difference if it's the same file and it's not randomized. So if you were copying the same file back and forth multiple times or reading the database multiple times, it should make a substantial difference there. Okay, I just did that so to show you the stats. Now you can also do this. Again, I'll post all of these below. Now this only does a quick check to tell you what's happening right this second. If you did that and then you added the number 2, it will refresh every 2 seconds. As you see, now that's giving you the zpool IO stats. It's telling you what's being written, what's being, you know, just a brief. It's not the greatest tool in the world. Now one other thing you can do with XCP-NG, now I've already done it on this one. You would install netdata. Oh, sorry, that's not the command. You would do yum install netdata. Now I already have it installed. Then you would enable the service. Oh, sorry, start the service, then enable it at startup. Okay, and what we'll get with that is if you go to the interface there for that particular server, if I didn't just break it. I'm not sure, seems maybe because I ran the command again, it shouldn't have broken it. That looks already fine. I'm not sure why. Or is it? But if you haven't used NetData, it's a great tool to check the system performance of the whole machine. You can use NetData on your Linux machines. I don't know, I think it gives you 5 or 10 free. The local one you've got unlimited, but if you want this all centralized in the cloud and just used via net data, their website, it will give you statistics on everything. One other thing I forgot to mention, now we can actually do a benchmark on the pool. Okay, so if we go ls, we're just going to go to the main directory, mysaspool, oh, okay, cd, okay, ls, so this is the VHT from the VM that we're using before. Now obviously we've got a VM already running in there. Okay, that's not what I was going to copy paste. I will leave all the links below. So what this will do is, I think it's meant to be creating a 50 gig file, and it's going to be telling us about it. So can we actually look at these statistics here? Oh, that one that I have. I guess not. This must only be keeping track of XCP-NG data. Now, one of the reasons I was going to show you net data is because it will show you the performance of all the disks. So this is going to be generating a 50 gig file and quickly reading it, I think, from memory. I will post a few other things that you can do to benchmark this. Okay, come on, some of us have places to be. I actually need to leave 2 minutes ago, so I will finish this probably when I get back. But I think we're pretty much done. So I showed you how to create the pools. I've shown you how to add the L2 arc, how to fix your ZFS pool. All of this applies to Linux as well, Ubuntu, pretty much everything out there. Now what you generally want to do, since this is XCP-NG, it does not have the latest ZFS. There is a ZFS update command that you can run periodically after you've done your updates, or if ZFS ever has an update. I think it was just sudo ZFS upgrade from memory. That will basically upgrade the pool with all the new features that ZFS has to offer. Come on, file. Some of us need to be places. Maybe I should have made it a 10 gig file, but hey. We're almost there. I'm going to pause this for a second. I'll be right back. Now, as you see, the read performance, it tells you how long it took to make the 50 gig file. Read performance is about 321 megabytes. Now again, I performed this on the SAS disks. They do have the L2 arc. I'm gonna actually kick this off and then run, and I'll see what the speed is like before and after, because we do have that L2 arc, to see if the L2 arc will actually make a significant difference. So I'll be back in about an hour. Now there is one more application you can do to benchmark this. It's called FIO. Now the way you install it, you do sudo yum install FIO. You can technically do this for other things from the REPL repo as well. And you just install it. Now I already have it installed, and then you can do commands like this. So Now we're already in this repo that we're gonna test. You would just browse to the appropriate repo and then you would just run the fio command. Okay, this is gonna take a couple of minutes. Again, 50 gig file. Now up here, so what we basically discovered, the arc cache didn't really help, but that could be because the file is randomized, so it would technically be a different file. It makes a fake 50 gig file of random data, but we got consistent reads there. So as we can see, this is writing 50 megs at 350. Now we are on the SAS data set, 300, 400 megs. Okay, we're almost there. I might just switch myself to the NVMe dataset just so you can see some big numbers or bigger numbers. Now the NVMe only has 2 in Z1, so it won't be amazing. And I don't know if this is plugged in, or PCI Express slots this is plugged in are actually running at full speed for the NVMe. Oh, sorry, I had to scroll down. So this is basically the info we got. So this is via FIO. So all I've done is browse to the NVMe directory, and we're just gonna run the same test again. So let's see what we're getting here. So we're getting 1.5 gigs. As I said, this runs in Z1, so it's writing to both at the same time. I'm pretty sure that's some form of penalty there. And I'm not sure if that disks or those disks are actually running at full speed. Because this is just a little adapter running in PCI. In the PCI Express slots on the motherboard, and this motherboard has a fair amount 4 times. Alright, so that's stabilizing to about 1 gig. Now this does not have the level L2 arc, and I don't know if these randomized tests it will do any difference regardless. Okay, so we got about 1500. I'd expect the same thing, the same test to be run again to produce the same results. Now I think I'm gonna end the video here. Have a good day, and I hope you guys enjoyed this. Unfortunately, I have had a lot of projects that I had attempted to run, but I couldn't make them function in an easy to understand manner, so I've just written them off. So hopefully I'll make something again in the next couple of weeks. Have a good one, and bye.